You wouldn't expect a seafloor south of mainland Australia to hide something colossal. On the surface, it's just another stretch of quiet ocean, rimmed by the Gippsland coast. But less than 100 kilometres offshore, about 60 miles, the Earth falls away into a landscape so large, so deeply carved, and so strangely engineered by water and time that it barely seems real. It's a canyon system so vast that if you drain the ocean tomorrow, southeastern Australia would suddenly look like someone had torn open the planet with a geological scalpel. What makes it even stranger is the silence surrounding it. Australia has famous onshore gorges, deep river systems, dramatic escarpments, but almost no one talks about the system sitting off the edge of the Bass Strait, even though it overshadows them all. And the reason is simple: this canyon doesn't live in the world we walk on. It's a giant carved into the abyss. A hidden amphitheatre more than 161 kilometres, about 100 miles across, sliced with channels that run deeper than most of the world's mountain valleys. If you zoom in on the bathymetry, you see an enormous hollow in the continental slope, wide enough to swallow small countries, and crossing that hollow is a single canyon so long and so sharply defined, it looks like a continental scale claw mark. The name of this feature doesn't sound dramatic, but that almost makes it better. It's called the Bass Canyon. Just two words: understated, forgettable. But it's one of the largest submarine canyon systems on Earth ever to develop in a cool water carbonate environment. No coral reefs feeding sediments, no tropical rivers dumping millions of tons of mud. Instead, you get quiet shelves dominated by bryozoans, shell fragments, foraminifera, and cold water carbonates. From those materials alone, nature carved something that borders on impossible. But first, a call to action. YouTube's got this new hype thing now. Apparently, it boosts the channel harder than likes and comments combined. So if you liked the video and want to genuinely support the channel for free, hit that hype button and let the algorithm know we exist. Thank you so much for your support. The canyon itself stretches roughly 160 kilometres from its head to its deepest point, cutting down from the shelf break at around 150 metres or 500 feet of water to depths of more than 3,000 metres or 10,000 feet. The walls in places rise nearly 1.3 kilometres above the canyon floor. The main trunk is up to 10 kilometres wide or 6 miles, straight and flat-bottomed like some kind of underwater highway. And it's not alone. South of it lies the narrow, more sinuous Flinders Canyon, and around them a whole network of tributary cuts feeding into a 160 by 160 kilometre amphitheatre that looks like it was scooped out of the slope with a single enormous hand. The first surprise is that this canyon system is not old. Not in a geological sense. The rocks around it have deep histories tied to the breakup of Gondwana and the filling of the Gippsland Basin with lakes, rivers and deltas during the Cretaceous and Paleogene. But the canyons themselves were carved in three main phases, with the most dramatic carving happening incredibly recently. The modern form of Bass Canyon, the one whose walls show up so clearly in bathymetric data, only emerged in the last 2 million years. That's yesterday on a geological clock. Australia's inland rivers, the ones people know, the Darling, the Murray, the Fitzroy, look ancient by comparison, yet none of them carved anything remotely as large as what happened offshore. To understand why, you have to picture something counterintuitive. A canyon system shaped not by rivers or tides or glacial low stands, but by a cold underwater waterfall. Every winter, Bass Strait fills with dense, chilled, highly saline water. This water, pushed by westerlies and strengthened by seasonal currents, reaches the edge of the continental shelf and simply drops. It sinks beneath the warmer, fresher waters of the Tasman Sea and plunges down the slope in a thick, unstoppable gravity flow. This plunging mass, known as the Bass Cascade, behaves like a submarine landslide made of water. It hugs the seafloor, racing downhill, picking up sediment, accelerating, scouring and deepening wherever the path takes it. Over time, that path became the Bass Canyon. What makes the story even stranger is that the canyon heads, the places where these chasms first bite into the shelf, weren't always dramatic. In the early Pleistocene, they were broad, gentle U-shaped valleys, not particularly impressive. But then something changed. Around 1.95 million years ago, carbonate production on the Gippsland shelf skyrocketed. The shelf was suddenly carpeted with skeletal debris. Bryozoans, mollusks, foraminifera, all pouring downslope in vast quantities. With so much sediment piled up near the shelf edge, the environment became unstable. Pulse after pulse of debris slumped toward the deep basin. And just as that happened, the Bass Cascade intensified. The combination of high stand sea levels, a thickened water column, and enhanced density contrast made this seasonal underwater plunge far more powerful than anything seen before. The result was catastrophic erosion. Those mild U-shaped channels were instantly reshaped into narrow V-shaped chasms. The canyon heads deepened into incised zones with walls as steep as 35 degrees. The tributaries lengthened offshore, cutting backwards into the shelf, and the whole canyon system began evolving far faster than any normal continental margin. Instead of slow, steady incision, the Bass Canyon experienced bursts of deep erosion triggered by density currents rather than traditional river-like processes. Even more unusual, the canyon heads didn't stay in one place. During the Middle Pleistocene, between roughly 950 and 470,000 years ago, the outer shelf canyon head channels filled with new carbonate sand and mud. Once filled, the canyon heads began migrating laterally across the shelf, mostly toward the northeast. It's a behaviour more commonly seen in river deltas than in submarine canyons, but here it was driven by the relentless direction of the Bass Cascade. Every winter, the cascade surged northeast along the shelf edge, pushing the canyon system sideways over time. The result is a geological structure that doesn't simply cut downward, it drifts, adapting its position as ocean currents rearrange the seafloor. Meanwhile, the upper slope canyon heads, the deeper reaches, remain non-depositional. They didn't accumulate sediment like the shelf segments did. Instead, they stayed bare, actively scoured, continuously exposed. In these places, the seafloor shows Pliocene sediments directly at the surface. The canyon is still alive down there, still active, still evolving in slow motion. When you take these pieces together, you realise the Bass Canyon isn't just a big hole in the seafloor. It's a dynamic system that has responded to ocean circulation, climate shifts, carbonate production pulses, and subtle tectonics over millions of years. It has removed something like 80,000 cubic kilometres, about 20,000 cubic miles of sediment from Australia's southeastern margin. And at the same time, the canyon has helped prograde the continental slope seaward by more than 100 kilometres or 60 miles, reshaping the coastline even as sea levels rose and fell. What makes this canyon system even more compelling is that it sits in a place no one associates with extremes. Bass Strait is shallow and unassuming. Fishermen cross it, ferries cross it, people think of it as a bland stretch of water. But beneath its eastern outlet lies a canyon network so large you could drop the entire Blue Mountains into it and still have room for half of the Victorian Alps. It's a landscape that challenges the usual rules. It formed during high stands instead of low stands. It was carved by density currents instead of rivers. It evolved from U-shaped to V-shaped instead of the other way around. And its position on the shelf has shifted sideways through time, guided by a winter current that most Australians have never even heard of. What makes this even better for storytelling is that the canyon is almost entirely invisible to the everyday world. If you stand on the beach at Sea Spray or Woodside or 90 Mile Beach, there is no hint that the ground beneath the waves collapses into a multi-kilometre deep amphitheatre, just beyond the horizon. The ocean hides the truth perfectly, but the moment you peel back the water using bathymetric data, you're looking at one of the most extraordinary, least discussed geological features on the entire Australian margin. And perhaps the most intriguing part is that very few people know this system exists at all. You can mention Carnarvon Gorge or Kings Canyon to anyone, and they picture dramatic cliffs rising from red desert. But if you mention Bass Canyon, most people think you're talking about an inland valley or something near Tasmania. Almost no one realises it's a colossal submarine canyon carved into the continental slope, shaped by Ice Age oceanography, and powered by a cold descending current that tilts the canyon sideways as it grows. When you look at these canyons in bathymetric imagery, the story becomes even clearer. The Bass Canyon's main trunk is unnervingly straight, like it's following a structural grain cut into the basin's Miocene and Pliocene sediments. To the north, you see the sprawling amphitheatre where multiple tributaries converge. To the south, the Flinders Canyon twists sinuously, almost like a drowned slot canyon. Together they form the Bass Canyon system, a pair of deep conduits delivering carbonate sand, mud and debris flows into the abyss for millions of years. Behind all that complexity sits the Southern Ocean, humming away with its enormous conveyor belt of currents. The interplay between westerly winds, the Lewin and Zeehan currents, and the winter-driven Bass Cascade has given southeastern Australia a canyon system unlike anything else on the planet. And even now, the Cascade still plunges down each winter, still shaping the canyon in tiny increments that accumulate over geological time. The quiet surface of Bass Strait has no reason to reveal what's underneath, but once you know it's there, you can't unsee it. You start looking at contour maps and bathymetric models and you realise that nature has been carving this margin with cold water and carbonate sediment for millions of years, long after the rivers of the Gippsland Basin stopped shaping the land. It's a canyon built not by rainfall or glaciers or mountain uplift, but by the ocean itself. sculpting the continent from the outside in. And that is why the Bass Canyon system might be one of the most extraordinary geological secrets off the Australian coast. A canyon so large it borders on mythic, shaped by forces most people have never imagined, quietly deepening and shifting beneath a patch of ocean so ordinary that millions pass over it without realising they're crossing one of the greatest hidden landscapes in the country. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.